Okay, I'm inside of AWS Cloud 9 here, and I want to work with some CSV files. Fortunately, it's very straightforward in Rust. So what I'm going to do is I'm going to first create a new project. So let's go ahead and say cargo new CSV demo. Great. Now that I got that, I'll go ahead and get into this project, and let's go ahead and check it out. So we've got CSV demo here, and we have a cargo file that we're going to need to add a library to. So in order to do that, what I'll need to do is toggle to a library that we can use. So let's go ahead and use CSV itself, appropriately named. Let's go ahead and put that in. CSV. Now, one of the nice things about the Rust language is I can also look at the CSV documentation here and just see what's going on. And we can see here, okay, it looks like there's a 122. So maybe that's the version we actually want to play around with. Okay, perfect. Now, the next thing that we can do is go to the main function here, and we have a hello world. So I first can just make sure everything runs. Looks like it was able to pull on that package, but I actually am going to look at the official docs here and copy what is actually running in the official docs. So I'm going to go ahead and make a data directory, which is a nice way to structure a project. And then I'm going to copy this data right here that is from the sample and put this into my project. And let's go ahead and just take a look real quick what this does. So we say example, CSV reader from reader.io, et cetera, and then we have a main here. So really the heavy lifting is this mutable variable RDR, which is a CSV reader, and it's going to essentially print out the records in the CSV file. So what do we need to do next is inside that data directory, I'm going to go ahead and create a file that has some data inside. And so I can do that by looking at a file here that I've got prepared, and we could just say touch data and just call this text.txt. And then I'm going to paste in some sample data. And let's go ahead and do that. Perfect. Now, all I need to do to get this thing cooking is actually to run it with cargo. And so that should be also pretty straightforward because Rust has such great support for running utilities. So let's go ahead and do cargo run. And I can just say here data, and we can say text.txt. What happens? There we go. We're able to actually read in those records. So really, really straightforward in Rust. In fact, maybe you could say it's more straightforward than many scripting languages because of the fact that I can bundle all this up, put it into a binary, and then give it to somebody else. Let's take a look at Cargo Lambda, which allows you to have Rust functions on AWS Lambda in a really simple way. In many cases, I think it's the easiest possible way to develop in any language for AWS Lambda. There's nothing needed. There's no weird workflows. It is a very straightforward process. So let's go ahead and first take a look at what you need to do. So in order to install it, one of the ways that you can install it is to use Homebrew. So in this case, you'd need to install Homebrew on a machine, let's say Cloud 9, and then that's it. And then all you have to do is do cargo lambda new project and then dive into it. So now that I know that that's what we need to do, what I'm going to do is I'm going to show you something that I've got set up, which is first I have the Lambda EFS set up here. So I'm mounting the Elastic file system on Lambda. I also have a Lambda already running here that's working. And let me show you how I developed it. So first up here, what I can do is take a look at this project, which is called EFS Lister. And inside of here, this is where all my code lives, which is nice. But I want to show the deployment process. So in order to do that, what I'm going to do is I'm going to show you that I can run cargo lambda invoke, and this will actually test this thing out locally. Now, this is going to fail because I don't have the cargo lambda watch working. So let's first see it fail. There's no emulator. So what's great about this cargo lambda service is that you can actually run it in watch mode. So if we go back to the docs here, take a look at this. What does it you can just say cargo lambda watch. Okay, let's do that. Let's go here and let's do cargo lambda watch. There we go. So it runs like a local emulation. It's trivial because again, Rust is a binary based language. I don't have to do weird Docker images or anything like that. So next up, how do I invoke it? Well, we can just do that same command. So we can just say cargo lambda invoke, and it's going to look for a running service here. In this case, the parameters I'm accepting are name, and there we go. So what it's going to do is actually interact with the actual code that the Lambda would run in production, which is it's going to list files on my Elastic file system. And what's awesome about this is I can also verify this because if I do ls dash l here, mnt efs, we can see that's exactly what is on my file system. So that's great, but what if I wanted to deploy this function and test it? Well, let's go ahead and read the docs here and let's see how this works. So first step, that's how you test it. That's how you invoke it. Oh, so you can do it with the API gateway, but what if we want to build a release? Let's go ahead and build this. So let's go ahead and go back here and let's build this release. So we'll say cargo lambda build release, and let's see what happens. Very quick. It's compiling everything we need. And once we've done the release, it's going to create a binary that we can use to do deployment, which in my opinion is the way to go for a service like AWS Lambda. Perfect. Now, what's the final step here is that we can do cargo lambda deploy. Now, notice you could even deploy to ARM64, which is awesome because it saves you a ton of money. And we go here, we do our release. There we go. Trivial, right? To deploy this. I mean, I can't think of anything that would be faster than using cargo lambda to deploy code. Now, what else can we do here? Well, we can do debugging, we can run GitHub actions, we can do et cetera, et cetera. So in a nutshell, I think cargo lambda takes something that is truly a little bit scary in scripting languages and makes it trivial. I would Cargo Lambda is a great way to deploy Rust functions to AWS Lambda, and it really simplifies some emerging workflows that a modern compiled language like Rust can do. In this demo, I'm going to show how Cargo Lambda combines with EFS, which is a mounted managed file system from AWS, to let you do really new things that potentially wouldn't be available without the serverless plus the managed file service plus Rust, right? It's the combination of all three. First, let's take a look here at EFS. So we see the Elastic file system. It's a thing of beauty because in this case, look, I'm only using 17 megabytes, and it can grow to terabytes. It can grow the disk IO automatically, but it's also this resource where I don't have to use it all or nothing, right? I don't have to, pay for, terabytes at a time. I can pay for what I need when I'm actually using it. So it's a great, ephemeral type resource to use in serverless workflows. Next up here, I'm going to use the Lambda, and this Lambda here, which I've already deployed, is an EFS lister here. And what's great about this is that I've gone through and configured so that the file system is actually mounted directly inside of this Lambda. So when it launches and it does whatever it needs to do, I've already got the ability to actually access it from the Lambda. So this is a very interesting pattern here where I'm not paying for anything. I'm not paying for the file system, I'm not paying for the Lambda until I actually need to use it. And because I'm using Rust, it's going to be incredibly efficient. So the question is, though, how do I actually develop against this? Well, one of the ways to do this is to use Cloud9. So with Cloud9 here, you can see here I've got some Rust stuff already set up. And if I go to Rust C dash dash version, we can see that Rust is already installed here. And what's really great about this as well is that I can also look at my history and figure out how to mount the file system that I've mounted before. So if I go back here, we can see here, oh, look, all I have to do is follow these directions. So I'm gonna make a directory here. So in fact, if I want to be lazy, what I can do is I can actually grab these, make a new file here, and just throw these commands inside, and then I can just follow them. So let's go back to here and just run these commands. So first step, we've got make a directory, which will be the mntefs. Oh, it already exists, so that's good. So in fact, if I've already done that, then what's great is we can see, does the mount directory already exist? So it looks like it exists, but nothing's mounted. So let's go ahead and mount it. Let's go ahead and go up a couple levels here. In fact, we can just go here and go back into our environments. And now I can just run this mount command. Perfect. And we can also run this command if it wasn't already run. I'm pretty sure I already ran this. And this will just double check that we've got the package. Looks like it was already done. And then from here, we can actually, if I needed to mount it again, or we can actually see what's inside that directory. There we go. So we see that there's stuff inside of here. So I've got, large language models, pre-trained models, whatever it is you want to put inside of here. And this is a great way to develop as well, right? Because I can just say, I don't know, I want to put a file inside of here, a new one, and we'll just say mounts EFS, and we'll call this demo video. I was here.txt. And now if I do ls, here we go, demo video, I was here. So that's all working. Now let's look at the code here and see it actually in action. So I'm going to go to the checkout of here that I have the code that will talk to this. And this is going to be in EFS lister. And now let's go ahead and take a look at what that code actually does. So here we have the cargo file first. Let's pull that up. And the dependency here is that we're using the Lambda runtime, and we're using the recommended libraries like Tokyo and tracing that they recommend with Lambda. And also that, again, I'm using the Cargo Lambda system to deploy it. Next up, we also have the source. And if we go through here and we look at the main here, I have some code that deserializes and serializes the data. I also have the ability to do the helper function that lists the files in the EFS volume. And you can see here, it's pretty straightforward. I just asynchronously read this inside my Lambda and I run it. And then finally, over here is where I pull it together in my Lambda function. So it's in many ways pretty similar to, let's say, AWS Python with Lambda, except for it's extremely efficient and is a very easy deploy process. So now that I have all that stuff cooking here, I then pull it together in the main function. Now, how do we run this? Well, I could run it from the terminal here. That's one way to do it. Or I also could just run it from the EFS that's already deployed. So let's go ahead and test this thing. And I believe that just a hello world test should probably be fine. We can just leave those values in, or I could even do an empty payload. Doesn't matter either way. Let's just do an empty payload, and let's save this. We'll just call this test. And here we go. And it says that there's a problem. It's saying, a missing field name at line 1. Okay, so to test it, it's going to need a name field. So let's just go ahead and say name, and we'll just say, test. All right, let's go ahead and save it, test it again. And there we go. We're able to actually get it cooking here, which is great. And now look, it gives us what's inside, and we should see exactly the file that I created, which is demo video I was here. Now, a couple other things to point out here is, look at this, the build duration, 14 milliseconds, right? I mean, this is just amazingly efficient. Also, the memory is extremely efficient as well. So this is something that is not really in the realm of what a scripting language can do. It just can't do the things that a Rust-based efficiency can do in the deployment, as well as trivial because it's a binary that gets pushed over here. So in a nutshell, to summarize what we're doing, that EFS is an emerging standard that mixes with Rust and also the AWS Lambda ecosystem for large language models, for data engineering. And really, it should be something that your organization investigates. If you take a look at this code here, this is pretty straightforward. There's not even 50 lines of code to get this Lambda cooking. And we know